Video we will look about a computer programming project presentation for group 1. Okay, first, what is Python? Python is an interpreted object-oriented high-level programming language with dynamic semantics. Its high-level built-in data structures combined with dynamic typing and dynamic binding make it very accurate for rapid application development as well as for use of scripting or glue language to connect existing components together. So that is what meant by Python. Okay, it's a program software. Okay, next is process of development in Python. So there are 4 major steps, which are the first one is planning and organizing. So planning and organizing need to follow the requirements given in the project. Second is coding, insert the coding using the Python programming software. Third is testing, where you need to test the acceptance of the project and execution and outcome. So where you'll get the outcome of the project. So analyzing using Python. So these are the project given. So nodes need to be required down there. Okay, so now we will look at the for the coding part from the program using Python. Okay, so the first one is we insert the value of the number. Okay, the teacher here. Okay, so the next one we use for the calculate the program. So calculate the program, the first thing is you need to import math. Okay, the next one is from tabulate, import tabulate. That means that you need to install pip, install tabulate first, then only you can insert the coding from tabulate, import tabulate. Then you go to, if not you will get a syntax error. Okay, the next one is import variables. Okay, import variables for the a, b, c, d, which is you need to enter the float input, the udl span for a, b, b, c, e, c, d, and then the length for span d, e, a, b, d, e, b. Okay, so and then the d1 is the point load of d. Next one is length of span. Length of span, you need to enter the x, y, z value. Okay, for the length of span to calculate the fixed end moment. Okay, so the next one is invalid input. So to check the invalid input, if it is equals to 0, means you need to re-enter again the variables or re-enter the length of span to avoid invalid errors. Okay, so the next one is fixed end moments. So the fixed end moments, we use the import math power, so that you get the value and the power of 2. So and then the round. Okay, round to the 2 decimal places. Okay, so to find, after that, find the stiffness factor, which is the k. Since the ai is constant, can be cancelled out, so we use round for /y, x, y, and z. Okay, so the stiffness factor for e and ed is equals to 0, de to ed. And then next one is distribution factor. Okay, distribution factor you use 1, and then for the final one is the de and ed is equals to 0, because since the stiffness factor is equals to 0. Okay, next the carryover factor. So all is the same except for de equals to 0, and the carryover factor we use is 0.5. Okay, the next one is initial movement in each member. So we use the balancing for each udl, ab, bc, cd, and de. Okay, and then calculate the end moment. So calculate end moment, we got plus with the fixed end moment for each udl plus with the balancing part. Okay, and then the store the df fixed end moment first balancing into the table. So we got the value. This one into the table is means that we need to the program outcome will be in table form. Okay, so next while the loop. Okay, so find the balancing, calculate the new balancing again, store results for this iteration, continue. Okay, and then calculate the end moment. Okay, end moment plus with the balancing, and then new. Okay, then after that we can find determine the direction force at each support, means support a, b, bc, cd, and de. So we will get the each support reaction, and then we can find the total reaction also. So the next is we use for the headers. Okay, and then member, and the end movements we use for the MAB, MBC, MCD and MDE for end movement, and then print the result in table format. Okay, so now I'm going to enter here. Okay, so I'm going to enter the UDL for A. So A we enter 0. Okay, and then we enter 5.0 for the length of the UDL span. Okay, and then the enter UDL is 20. Okay, C and D is 40. It is point load, so it's 40. And then for each enter the length, so we enter 20, and then the xy is 30. We enter the value, and then length of span B as Z value is 25. Okay, so here we got the each member in the table form, AB, BA, BC, CB, CD, DE. So distribution factor, stiffness, and the balancing, and then the end moment. So here the final one, here we have the reaction A, B, C, D, or the values are respectively. So these are the outcome of the program that we got. Okay, so for the conclusion part, to sum up, this Python project successfully illustrates the strength and adaptability of Python in handling challenging issues. So we accomplish our goals. Thank you.